Today we're going to be solving differential equations by separating variables. An example of one of these equations would be 2 dy dx, clean that up, equals y x plus 1 all over x. So the first thing we're trying to do when we're trying to solve differential equations by separating variables is we're trying to put all the dy's with the y's and all the dx's with the x's. So the first thing I'm going to do, I'm going to divide by y here so that this y cancels out and moves over to this side. So it would look like this: 2 dy dx all over y equals x plus 1 all over x. Now that we have the y over on the left side, we're trying to move the dx over to the right side. But first, let's clean up this fraction. Here we know that x over x plus 1 over x, this and this are both the same thing. So we're going to cancel out these, and this becomes a 1, and that stays the same. So our new equation will look 2 dy dx all over y equals 1 plus 1 over x. Alright, now that we clean this up, let's try and move the dx over to the right side. And to do this, we need to multiply this side by dx and also multiply this side. So our equation will be 2 dy over y equals 1 plus 1 over x and all that times dx. Now, we multiplied the dx, but whatever it's inside the fraction. So we get 2 dy over y equals dx plus 1 over x dx. Alright, now that we have all the dy's and the y's and all the dx's and the x's on the same side, it's a lot easier to solve the differential equation. And then we clean this board up real quick. Yeah. Alright. Now that we agree on that formula, now we try to solve the differential equation. So we'd write the integral of 2 dy over y equals the integral. We can put 1 times dx is the same as dx, just I like putting the 1, plus 1 over x, integral 1 over x dx. Alright, now that we clean everything up, it's a lot easier to solve the differential equation. Because we know dy over y would simply be, first, I'll move the 2 out of the integral. So now, all we need to do is solve it for dy over y, would be 2, because the 2 stays the same. And dy over y equals ln y. And this equals, then we know the integral of a constant would simply be the constant times the variable. So this is 1, so it'd just be the variable. So it'd be x plus, and we know the antiderivative of 1 over x is ln of x. And then we add plus c, because we didn't get numbers to find what c equals. And we add c on the right side, but it doesn't really matter because it's a constant. You can add it on either the left or the right side. And then we are